Okay, so we have S is the region bounded by that graph. I want to find the area of the region S. So what I need to do is I need to find the intersection point of those two. And it looks to me like they're intersecting at x equals 2, but we can just check. If I plug in 2 into 2 squared plus 1, I get 5. And if I plug 2 into 9 minus 2 squared, I also get 5. So they do actually intersect at x equal 2. So I want to do the integral from, and I'm looking at slices like this. So the integral from x equals 0 to x equals 2 of the top slice is given by 9 minus x squared. I want to subtract the bottom part out. So minus x squared minus 1 dx. So that's the integral from 0 to 2 of 9 minus negative 1. So 9 plus 1 is 10. And x squared, I have negative x squared minus x squared, so minus 2x squared. And so if I find an antiderivative for that, that's 10x minus 2x cubed over 3. I want to evaluate that from 0 to 2. So if I plug in 2 for that, I get 20 minus 2 times x cubed. X cubed is 8, so 8 times 2 is 16 thirds. And then minus, and then if I plug in 0, I'll get 0 minus 0, so that doesn't matter. And so I end up with 20 minus 16 thirds, which reduces to 44 thirds. Okay, on part B, it says the vase is the function shown below and has horizontal cross-sectional areas given by that function. Write an integral that represents the volume of this vase. And so if I think about this as my axis, and then this is my, oh, actually that is the area, isn't it? That's the area function. So I want to integrate those areas from 0 to 10. And so, so I'll have pi times 0.4 sine of 0.7x plus 0.2x plus 1 squared dx. So I'm just really integrating that area function from 0 to 10. And it says do not evaluate, so we're done. On the next one, it says the graphs are the function g. Write an expression that represents the numerical value of the quantity identified on the corresponding graph. Select the appropriate expression. Only from the options below. So if I look, well, okay, so let's do this one first. So this looks like the integral of g of x from 1 to 4. So that's this expression here, represents this area. So the integral from 1 to 4 of g of x dx. And then here, I want to find the slope of the line tangent to the graph at 2, 2. So the slope of that line will be the derivative of g evaluated at 2. And so that's given by, this one is the definition of derivative. So that will be limit h goes to 0 of g of 2 plus h minus g of 2 over h. So that's the definition of derivative with 2 plugged in for x. The next one says the sum of the area of the rectangle shown. So it looks like this region is broken up into 3 pieces. So this is going to be some kind of a Riemann sum. And so, so it's going to be, so this is going to be 1 times g of 2 plus 1 times g of 3 plus 1 times g of 4 is what that area represents. And if I want to write that in sigma notation, it will correspond to this one, actually. So because it's going to be g of 1 plus k, because it's going to give me one more, because I'm doing a right-hand sum. So this is the sum from k equal 1 to 3, g of 1 plus k times 1. And this last one, it says the slope of the secant line, which passes through these 2 points. Okay, and so that's going to be just this slope formula, g of 4 minus g of 0 over 4 minus 0.